I'm getting everything pulled up. Okay, so are we just going over the answers and stuff?
Yep.
Okay, I need a notebook. Where is a notebook? Okay. We have a quiz today too, but it's just like the answers from the exam, right?
Yep.
Okay.
We're supposed to pick the hypothesis test that fits this. So, in an article in the Journal of Small Business Management, successful startup businesses in the U.S. and Korea were compared. One set of data compared educational level, high school, undergraduate degree, master's degree, doctoral degree, of people who manage successful startup companies in the United States and Korea. You want to determine if education levels differs between managers of successful startup companies between those two countries. Which hypothesis test would be most appropriate? And I was thinking it would be the chi-squared test of independence.
I don't even remember what this chi-squared was.
It's the one that's a table, and I thought it would be that because it's categorical data on both sides. Well, not categorical, but there's a lot of categories.
Oh, high school, undergraduate degree, master's degree. Okay, yeah. Okay. A human resources manager reported data from a recent involuntary reduction in force at her company. You are an attorney and want to determine if age discrimination was a factor. It is illegal to discriminate against employees because of age. The company reported the number of employees in two groups, 40 years old or younger and over 40 years old. They also reported the number of employees in each group who were terminated. You want to determine if both age groups were treated equally. Which hypothesis test would be most appropriate for this analyst? And two samples independent?
Yeah, that's what I'm confused about because it would make sense, but I know that if someone's not in the under 40 age group, they're going to be in the over 40 age group. So would it be independent or matched pairs?
Oh.
Like, I'm not sure.
Okay. Oh. Okay. They're dependent then, right? Wait.
I know that if it's matched pairs, if it's matched pairs, then knowing group 1 will tell you group 2.
Then I would say it's that, because if you know they're in the 40-year-old group, then you know the other group is.
Yeah.
So I would say it's match pairs.
Okay. A survey was conducted by a group of state lotteries. A random sample of 2406 adults completed the survey. A total of 248 were classified as heavy players. Of these, 152 were male. You want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population, which is 48.5. Which hypothesis test would be most appropriate for this analysis? And it's a one sample.
T-test?
I don't know if it's a t-test or a z-test. What is z-test again?
I hate these ones. A z-test.
Okay. A z-test is when sigma is known, and so we don't know sigma because that's standard deviation. So it would be t-test. Right?
Yes. Wait, so the known is a z-test?
Yeah, known is a z-test, unknown is a t-test.
Okay. Hold on, I'm just looking this up really fast. Okay, sorry. A student project compared the effectiveness of two different combination locks. One of the locks turned clockwise first and the other lock turned counterclockwise first. They asked 25 students to participate in the study. Each student was given a combination to each lock and asked to open the locks. The time it took for them to open each lock was recorded. They want to determine if one of the locks is easier to open, which hypothesis test would be most appropriate. The test of two proportions.
Test of two proportions? Why? I'm just trying to understand.
Wait, is the proportions for categorical?
Yeah, proportion is the percentages one.
Oh, then I would say independent sample t-test. Right?
This is so confusing.
Which one is supposed to compare? Because that one doesn't matter. Like, they don't, it's not dependent on each other, right?
Then it was independent, right?
Yeah, so wouldn't it
Yeah.
be an independent sample t-test? Because then that's two?
Yeah, I think you're right.
Okay.
Okay, so I was going back and thinking about it, and the first one, I don't think it's chi-squared, because chi-squared is for independence, and we're not trying to figure out if educational level and success is dependent or not. So I think it's ANOVA.
That would make sense, because ANOVA is for, like, different samples.
Yeah.
Okay, yeah, I agree.
Okay, so now we're deciding which confidence intervals to use. A bank employs two appraisers. When approving borrowers for mortgages, it is imperative that the appraisers value the same types of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers have recently valued. Which confidence interval would be most appropriate for this study? What did I say? I said T, but I don't think that's right.
Would it be paired samples?
Yeah, I think that sounds better.
I always get confused on these ones, like, yeah.
Yeah.
Okay. In a Wall Street Journal article on satisfaction with career paths, the percentage of psychology majors reporting they were satisfied or very satisfied with their career path was reported. The same data was also reported for accounting majors. You decide to construct a 95% confidence interval to see if the observed difference is significant. Which confidence interval would be most appropriate for this study? An independent sample T confidence interval?
That's what I said.
Okay.
Okay. Well, my questions went away. Okay. Double stuffed Oreo cookies are supposed to have twice the filling of regular Oreo cookies. You and some friends decide you want to know if there is it is a true assertion by the company who makes them. You take a sample of 55 double stuffed Oreo cookies and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true mean filling of double stuffed Oreos in order to compare it to the filling amount found in regular Oreos. Which confidence interval would be the most appropriate? I said one sample T.
Why?
Because right then we're just figuring out a confidence interval of double stuffed Oreos. So there's only one sample. And okay, we don't know the population standard deviation.
Okay, yeah. Okay. Which of the following best describes the notion of the significance level of a hypothesis test. The probability of rejecting HO, whether it's true or not, the probability of observing a sample statistic more extreme than the one actually obtained, assuming the null hypothesis true. That's the right one, right?
I thought that it was the probability of a type 1 error.
Oh gosh, I don't remember. I remember putting that for something. Maybe it was the p-value. On number 9, would you put that as the p-value then?
Yeah, that's what I thought the p-value was.
Okay. Wait, I'm confused. Okay. The significance is the probability of type 1 error. Okay. Yeah, we'll say type 1 error for 8 and then B for 9.
Okay. Okay. Suppose you create a 95% confidence interval for a mean and get 10 and 20. You've been told to report this by saying something similar to, we are 95% confident the true mean is between 10 and 20. Exactly what does this mean? I never know the answer to that.
Okay. Suppose you create a 95% confidence interval for a mean. I think it is that I think it's C. There's a 95% chance that the true mean is between 8 and 10. I know it's not D.
Okay.
And I'm positive it's not B either.
Because I know I get it wrong, like, every time.
I'm pretty sure it's C, but don't quote me.
Yeah, I'm going through, I know it's been on a homework quiz or something before, so I'm going through and just checking those real quick. I know the last test, but we can't see what questions went wrong on the test. It doesn't tell us.
I know.
Which homework was it on? Okay, so given a 90% confidence interval, it means that we are, oh no, never mind, that's one we already know. We are 90% confident the true mean heart rate, that the true mean is. Yeah, I have no idea.
I'm pretty sure it's C. Like I said, don't quote me.
Okay. Yeah, I know. Okay, and you're pretty sure it's not D, because that was my guess. So.
Oh no, I'm positive it's not D.
Okay. So use this information. You take a simple random sample of 100 adults from a town in the western U.S. to determine the proportion of adults in the town who invest in the stock market. Assume the unknown population proportion or percentage of people in town who invest in the stock market is P equals 0.30. What is the mean of the distribution? D, 0.30.
Okay. Hold on. Let me. I skipped one on my paper, so I'm like, ah. Okay, sorry. What is the standard deviation of the distribution of the sample proportions? And we have to figure that out.
Mm-hmm. Okay, so I just went and looked it up and I finally found it. And the question was, suppose you create a 95% confidence interval for a mean and get something. You've been told to report this by saying we're 95% confident the true mean is between this and this. Exactly what does it mean? And the correct answer was 95% of all 95% confidence intervals actually contain the truth.
I will not forget that one now. %95 of 95%. Okay. How do we figure out the standard deviation again? I am just all over the place.
It's the square root of p times 1 minus p over n.
Okay. N was 100, right?
Mm-hmm.
Okay. Okay, I got 0.045.
Thank you. So it's B. What
B?
is, yeah, 0.046. So it's
Okay.
0.0458. So what is the probability that your random sample of 100 adults will have a sample proportion less than 0.25? And I need to plug it into the applet. I got the z-score, but...
You did the z-score?
Mm-hmm.
Okay.
Z-score I got is negative 1.091. And the probability I get for that is 1.138, which is A.
All right. Okay. Alcoprol is meant to control hypertension. In clinical trials of alcoprol, 2142 subjects were divided into two groups. The 1563 subjects in the experimental group received alcoprol. The 579 subjects in the control group received a placebo. Of the 1563 in the experimental group, 61 experienced dizziness as a side effect. Of the 579 subjects in the control group, 15 experienced dizziness as a side effect. Let P1 be the true proportion of people who experience dizziness while taking alcoprol, and let P2 be the true proportion of people who experience dizziness but do not take alcoprol. Create a 95% confidence interval for P1 minus P2. Is that the two proportion one?
Yeah, just plug it into the Excel sheet.
Okay, I have to pull that up. You did 2 proportions though, right?
Yeah.
Okay. Sorry, this takes me forever.
It's okay.
Okay, I got let me even see if it's an option. I got negative 0.004 and 0.029.
Is it an option?
What?
Is it an option? Oh, sorry, it's not letting me scroll down right now. And I just wrote down what letter I got. So I don't know if that's one of the options or not.
I got D. C.
See, that's what I got.
Okay, good.
So, to see if the proportion of experimental group subjects who experience dizziness is different than the proportion of control group subjects who do. Let P1 be the true proportion of people who experience dizziness while taking active growth. Let P2 be the true proportion of people who experience dizziness but do not take active growth. Use a level of significance of A equals 0.05. So which of the following pairs of hypotheses is the most appropriate? And I said B. P1 is equal
B?
to P2 and P1 is not equal to B.
Yeah, that's what I would say too. Okay, the value of your test statistic is that's your p-value, right?
Nope, that's the what is it called in this one?
The z.
The z.
That always confuses me. I wish the letters stayed the same. Okay, 1.458.
Yeah. Yep.
Okay.
So I got 2. So D. The p-value is D.145.
Yeah.
Oh wait. Yeah.
I have 0.145. Okay, is there sufficient evidence to conclude that the true proportion of people who experience dizziness while taking Acropol is different than the true proportion of people who experience dizziness while not taking Acropol oral? No, because we failed to reject the HO.
Yeah.
So E?
Yep.
Okay.
A survey was conducted of 1,279 randomly selected adults age 18 and older. They were asked, are you a morning person or a night person? The hypotheses are being a morning or evening person is independent of age, and being a morning or evening person is not independent of age. The results are given in this table. Conduct a test of independence. Use a significance level of A equals 0.05. Calculate the test statistic for this hypothesis test. Assume the requirements for the test are satisfied. And I got A when I plugged it in.
We're still on a 2 proportion one, right?
Nope, this is a chi-squared test for independence.
Oh, which one is that? I don't have a tab for that.
You should. It's the third tab.
Awkward. I don't have a third tab.
That happened to me once, actually. I don't remember how I got it back, though.
Well, that's weird. I don't have a third tab. You're on the categorical data analysis one, right? With the 1 proportion, 2 proportion.
Yep, 1 proportion, 2 proportion, and then chi-squared.
What? Why don't I have one? What if that happens during a test?
No, that's too bad. Reopen it, maybe? I think that's what I had to do, just open it again.
I've reopened it 3 times, and it's still not there.
Oh, that's weird.
That's weird.
Well, the answer that I get is 6.58.
Hold on, let me see if I can pull this up really fast. Yeah, I don't have it, so now I'm gonna have to look for it. It is so weird. Okay, what did you put then?
6.58. So A.
Okay. And then 20. I can't get
the p-value is 0.087. So D.
Okay, should you reject the HO or not? No, because the p-value is greater than 0.05.
Yep, that's what I said too.
Okay, so E?
Yep. You have sufficient evidence to conclude that age makes a difference in whether a person is a morning or night person. Why or why not? And no, I failed to reject HO, so F. Yep.
Okay. A recent book noted that only 20% of all investment managers outperformed the Dow Jones Industrial Average over a 5-year period. A random sample of 200 investment managers that had graduated from one of the top 10 business programs in the country were followed over a 5-year period. 50 of these outperformed the Dow Jones Industrial Average. Let P be the true proportion of investment managers who graduated from one of the top 10 business programs who outperformed the Jones over a 5-year period. Based on the results of the sample, a 95% confidence interval is performed for P. What kind of test is that? 1 proportion?
A 95% confidence interval for P. I think it would be 1 proportion, yeah.
Okay. That is so weird that it won't open up. Ugh.
It won't open any of them now?
No, I have the 1 proportion and the 2 proportion, but the chi-square I don't. So what do I do when the test comes?
I don't know.
Okay. Is our null 0.2?
Mm-hmm.
Okay.
That's what I thought at least.
Okay, making sure. Then 0.195 and 0.315?
Yeah. Which is
B.
C, yeah. No, C.
Oh, is it 0.0?
C is 0.195 and 0.315, and B is 0.0195 and 0.0315.
Yeah, so it's C, right?
Yeah, C. I thought you said B.
Oh, no, I said C. I was like, wait a second, mine doesn't have an extra O in there. Okay.
Okay. Suppose you had been in charge of designing the study. What sample size would be needed to construct a margin of error of 2% with 95% confidence? Use prior estimate of 0.2 for the estimate. And I got B.
Hold on 2 seconds. Let me see what I got. Wait, what did you get?
B.
Okay, how do you find that out again? Which?
It's the 1.95 times, oh, 1.9, it's 1.9. What is the confidence interval number? I mean, the Z
1.9.
for that? 1.96?
Yeah.
That's why I cut off. Okay, so it's 1.96 divided by 0.02 squared, and then that number together squared, and then multiplied by 0.2 times 1 minus 0.2.
Okay, and you got B?
Yeah, I'm redoing it now because I just realized that I've been using the wrong number.
Oh, okay.
It shouldn't have changed too much.
Okay.
Yep, I got B.
Okay. Great. Okay. Suppose you wish to see if there's evidence that graduates of one of top 10 business programs performs better than other investment managers. Conduct a hypothesis test. Use a level of significance of 0.05. Which of the following paired hypothesis test is most appropriate for addressing this question? And it would be C.
Yeah, that's what I had to. So how many measurements must you have in order to assure that p hat is normally distributed? Then I said C.
Yes.
N times P. Okay, cool.
I would agree. Okay, the value of your test statistic is 1.768. So A.
Oh.
Oh, just kidding. Hold on.
Oh, no, that is what I have. Okay.
That's what you have?
Yeah, 1.768.
Okay. And the p-value that I got is 0.039.
Yeah, that's what I got too. Okay. So is there sufficient evidence to conclude that graduates from the top 10 business programs perform better than other investment managers? And I would have to say A. Yes, because I rejected
A. Okay. Computer software is commonly used to translate a text from one language to another. As part of his PhD thesis, Philip Cohen developed a phrase-based translation program called Pharo. The reality of the transition can vary. A good translation system should match a professional human translation. It is important to be able to quantify how good the translations produced by Pharo are. The Something Research Center developed methods to measure the quality of a translation from one language to another. One of these is the bilingual evaluation understudy. Blue is a score ranging from 0 to 1 that indicates how well a computer translation matches a professional human translation of the same text. Higher scores indicate a better match. Blue helps companies who develop translation software to monitor the effect of daily changes to their system in order to weed out bad ideas from good ideas. To compare Pharo's ability to translate with similar computer translation software, Cohen took a random sample of 100 blocks of Spanish text, each of contained 300 sentences, and used Pharo to translate each of these to English. The blue score was calculated for each of these 100 blocks. He wants to use these data to see if it differs from the mean blue score of another leading translation software which has a population mean score of 0.25. Open the data file blue scores. Assuming the requirements are satisfied, calculate a 95% confidence interval for the mean of blue test scores.
Okay, so I'm trying to figure out how we do that.
Okay. What test do you use?
It's one.
Would it be a one sample t-test?
I would think so. Which means I need to get over on some other software.
Yes.
So all I have right now is Excel because it's always needed for this unit.
Are we in agreement though, one sample t-test?
I think so.
Okay.
Aaron, could you please come fix whatever this crazy computer is doing? I tried to type in a password and it just freaks out at me.
Here's the keyboard, right? That's it.
No. That gets us with two problems. Every time I try to type in my password, it's like yelling at me and it pulls up all these weird windows.
Wait. What's that?
Ah,
I don't know why.
I'm opening up SBS.
okay, yeah, I was trying to do it, but I had to do apparent research.
Okay. Okay, what is the question asking?
So the first thing, we have to find the 95% confidence interval, and then calculate the degrees of freedom and the test statistic, and then calculate the p-value. There are no questions for any of these things, but then there's a question at the end that determines whether we
Okay.
or not.
Oh, there's no options. We just come up with it.
Yeah.
Okay, well, for the confidence interval, I got, that's the high and low, right?
Yeah.
Okay, I got 0.2824
Okay.
and 0.2928. And that's on SPS with a one sample t-test.
Okay.
The degrees of freedom are 99.
Okay.
And what's the next one?
The p-value.
Is that T? No.
P.
Is that the mean difference? Because it doesn't directly say what P is. Here.
You might have to plug the z-score into the normal probability applet too, or the t-score rather.
Oh, okay. Okay, well, the T is 109091. Wait, I don't know which number to look at. I'm so confused all of a sudden.
Oh, okay. So p-value on SPSS, or however many S's there are, is the SIG point thing.
Then it's 0.000.
Yeah.
Oh, okay. Okay, then moving on. Calculate the p-value. Oh, we just did that, right?
And based on the results of the test, what do you conclude? So we have sufficient evidence to say that the true mean is different than 0.295, so D. Right?
D?
Yeah.
Okay. Wait, what was the test statistic?
Oh, I didn't write that down. It was 109.091.
That is the test statistic, okay.
That was what it tells me, at least.
It just seems so big.
It does.
Okay. A study was done to test the notion that people are taller when they first wake up in the morning and then in the evening right before they go to bed. To test this theory, the heights of children in a boarding school in India were measured. You want to determine if the children are taller in the morning than in the evening. Open this file and define the differences of AM height and PM height.
So, paired sample t-test?
Yes. So let's see. Okay. Okay, give the test statistic for this test I got 0.000.
For the test statistic, I got 22.446.
I'm just kidding. Where am I looking? Oh, that's what I got too. I was looking in the wrong spot.
Okay, and for the degrees of freedom, I got 40.
I got 40 for degrees of freedom too, and then 0.000 for the p-value.
Me too. So we rejected it all. So 38 is A. Cool.
All right. Oh, the confidence interval too is 8.7, right?
Yep, that's what I got. And then 10.455.
All right, let's do this thing.
Yeah. Would you play that picture? Alrighty. So the first question, well, the first real question is, in an article in the Journal of Small Business Management, successful startup businesses in the U.S. and Korea were compared. One set of data compared educational level, and obviously startup companies in the U.S. and Korea. You want to determine if educational level differs between the countries, which hypothesis would be the most appropriate, and we said ANOVA.
Okay. A human resource manager reports data from the recent reduction force. Okay, where is it? You want to determine if both age groups were treated equally, which hypothesis test would be most appropriate, and we said matched pairs.
Which they have as paired sample t-test. A survey was conducted by a group of state lotteries. A random sample of 2,406 adults completed the survey. A total of 248 were classified as heavy players. Of these, 152 were male. You want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population. What hypothesis is most appropriate? We said one sample t-test.
Yes, we did. Okay, student compared the effectiveness of two different combination locks. One lock turned clockwise, the other turned counterclockwise. They asked 25 students to participate in the study. Each student was given a combination to lock. The time to open it was recorded. They want to determine if one lock is easier to open, which hypothesis test would be appropriate. We said independent sample.
Independent sample t-test. I hate these like fill in the box ones because if you don't type it exactly how they have it, you get it wrong.
I know, so you have to like look at it.
Weight gain during pregnancy of the mother is an important, this was not on the review, okay,
No.
an important indicator of infant health. A simple random sample of pregnant women in Egypt, Kenya, and Mexico was used to determine if weight gain during pregnancy differed in these three countries. Which hypothesis test would be most appropriate? Would that be ANOVA?
Well, it's three or more.
Yeah. And it's not independent, so
Yeah.
I think it would.
Yeah, let's put ANOVA. Pause. At the very top, it says, oh my gosh. You've been typing out the answers, huh?
Yeah.
At the very top, it says,
Oh, in the answer box, type the one.
yeah. Ugh.
We didn't have to say about the whole word. No. I'm glad you noticed that before we submitted it, because I would have been really upset if I lost all those points.
Right. Three is B, right? You have E, B, C, D.
I don't. I probably got it wrong.
Oh no.
I
Okay.
have E, C, A, D, E.
Okay, I got A, E, B, A, D.
C, A. Why won't it let me scroll now? E, C, A, D, E. That's what I have.
E, C, A, D, E. Where did I get B? Wait, 3 isn't C?
It's not? It's not paired samples?
Ugh. I put one sample t-test earlier.
But there's two samples. We have the employees in 40 and younger and the employees in over 40.
I'm getting thrown off because of that extra one. I don't know why. Okay, so E, C, A, D, E.
Yeah, that's what I have.
Okay, let's do this right this time. The two appraisers. Oh, this is going to throw me off now. That one is the paired samples, right?
Yeah. So C.
C.
In a Wall Street Journal article on satisfaction with career paths, the percentage of psychology majors reporting they were satisfied or very satisfied with their career path was reported. Same data was also reported for accounting majors. You decide to construct 95% confidence intervals. The reserve difference is significant. Which one is the most helpful? And it's
D.
independent sample. D. Okay, and this one was not in our question either.
Sorry, my roommate just asked me a question.
Okay.
You said one sample, right?
Yeah, and this next one, number 9, and this wasn't in our review either.
Okay, so we got C and D.
Yep.
Okay. Okay. O'Hare International Airport in Chicago has a reputation for having a large proportion of its flights being late. You design a study to see if this reputation is deserved. You find the average on-time rate for all international airports is 70%. You collect the data to determine on-time rate for O'Hare. You decide to construct a confidence interval to compare O'Hare's on-time rate to the national average. Which confidence interval would be most appropriate? Would that be an independent sample T confidence?
See, I'm trying to decide if it was that or the +4 confidence interval for 2 proportions, because it's a percentage.
Oh, then yeah, I'd do the +4.
Well, double stuffed Oreo cookies are supposed to have twice the filling of regular Oreos. You and some friends decide you want to know if this is a true assertion by the company who makes them. Take a sample of 55 double stuffed Oreos, measure the amount. You need to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos in order to compare it to the filling in regular Oreos. Which confidence interval do you use? And we said one sample T.
Yes, so B. Okay. Which of the following best defines the notion of significance level, and that's the probability of type 1 error?
And which following best defines the notion of a p-value, and that's the probability of observing a sample statistic, blah, 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 blah.
Suppose you create the 95. Okay, that one is 95% of all 95% confidence intervals.
Yes, I'm pretty
Never
sure that's what I
gonna
found going. Okay, you take a simple random sample of 100 adults from a town in the western U.S. to determine the population proportion of those in town who invest in the stock market. Assume the unknown population proportion or percentage of people in town who invest in the stock market is p equals 0.3. So what's the mean? And it's 0.3.
And then the standard deviation we said was 0.045.
Yeah.
So 0.046, yeah.
And then the probability is 0.138, right?
Yes.
This is totally throwing me off because I didn't write down the numbers. I just wrote down the letters, and now the numbering is off.
I know. I hate that. Ugh! I just wrote down all the letters too, man.
Yeah, I think we're the.
So those numbers are. I'm pretty sure it was C. It's still C.
The next one, 17.
Yeah.
Okay.
Were you still on 16?
I was just not sure we'd moved up, but yeah, I think that was okay. And then 15 was perform a hypothesis test. Let this be this and this be this, and we said that it was B, so equal and not equal.
Yeah. It looks like they're the same.
Yeah.
Okay, so the value is 1.458.
B. Okay, and the p-value is 0.145.
Yeah. And then we put no, I failed to reject the HO. Right?
Yep.
Here.
A survey was conducted
Go right ahead.
of some adults. They were asked, are you a morning person or an evening person? The hypotheses are being a morning person is independent of age, or being a morning or evening person is dependent. These are the results. Calculate the test statistics, and we got 6.580.
Okay. Calculate the p-value for the hypothesis test. I don't even remember what we had.
Okay, I'm trying to figure out what question we're on. Okay, so I think that we are on 20, so 0.087. But I'm going to go, I think I actually still have that in Excel, so I can pull it up. Yeah, okay. The p-value was 0.087. So yeah, D.
Should you reject or not? No, the p-value is greater than 0.05.
Yeah.
Do you have sufficient evidence? No, because we failed to reject the HO.
Okay, so recent folks noted that only 20% of all investment managers outperformed the industrial average in a 5-year period. There was a sample. So based on the results, a 95% confidence interval of P is C.
B.
C.
D as in dog.
I have C as in cat.
Oh, just kidding. Yes.
So that was the one that we misunderstood each other on.
The last time too, because I was like, wait, okay, yeah. Okay. Suppose you'd been in charge of designing the study. What sample size would you need to construct? And didn't we say B?
We did, yes. So using the following information, oh, sorry.
1537. Right.
Yeah. So suppose you wish to see if there is evidence that graduates of one of the top 10 business programs perform better than other investment managers. So which of the following hypothesis is most appropriate? And it's C.
C.
Mm-hmm.
How many measurements must you have in order to assure that P is normally distributed? And we said C.
The value of your test statistic is A, 1.768.
Yep. And then the p-value is 0.039.
And there is sufficient evidence to conclude, and because we rejected the no.
Yes. So A, right?
Yeah. Okay.
Oh, gosh. I did not answer one or more questions. What question did I not answer? Did you submit yours already?
No, I didn't. I almost did, and then I heard you say that, so I decided I'd wait until you figured.
What did you do? 20. I don't have 20.
20?
0.145.
0.145, yeah.
Okay. Weird. Okay, submitting. Not too shabby. Ugh. What?
Okay, we got all of the hypothesis ones.
Hold on. Okay,
That's the only thing we got wrong, though.
that's good. Well, that's good and that's not good. Okay. Wow. Okay, so I think you were right the first time that for high school, undergraduate, masters, it was the chi-square.
Probably. But we
That's
can see this tomorrow morning, which is good.
That's true. Okay, so the 40 years or younger, we said paired.
Yeah, I wonder if it was independent.
That doesn't make sense because, like, if you're not, ugh. Okay, and then heavy, and we said A. Oh, just kidding. I got
this used to be B. Yeah.
I put the wrong one. That one was my bad.
Yeah, me too.
Okay, and then 5 we put D, which I thought would be an independent.
Sample t-test.
But that would be a test of 2 proportions then?
Oh, or it could have been a paired sample t-test because you have to do both lots.
Oh. Okay.
But we got the one that we didn't talk about, right?
Right.
We got 2 of the confidence intervals wrong.
Okay, so the satisfied or very satisfied. I think that one should have been in paired samples too. I think that one's a paired samples because no other one makes sense to me.
Yeah, probably.
And then
We got all the ones that use math right, though.
that's good though. Okay.
I'm going to take us off the air.
Sounds good.